Welcome back to Bites of Pi. Today we're going to go over the inheritance quiz from AP here in 2020. This review will cover 8 questions found in the inheritance quiz. Question number 1. Consider the following class definitions. Here we have 2 class definitions. One is of robot and one is of android that extends robot. Now, the tricky part here is that robot and android both have a private int servo count. So note that these are 2 separate variables in 2 separate locations. We notice that get and set servo count will set the robot servo count here, and this particular method, the android set, the constructor will call the set servo count, which will set this variable here. Same thing with get and set servo counts functions will call these getters and setters, which will set this guy. But the get local and set local will specifically touch this variable. So in this following code, x is 10 and y is 20, we want to find which code chunk here will result in printing out 20. So y is 20, just keep that in mind as we go through these. The first one, Android A equals new Android X, so we're passing in 10. That'll call this function set servo count, which will set this particular servo count to 10. So keeping that in mind, this servo count value is 10. Then we say a set servo count y equals 20. So that calls this set servo count, which calls this set servo count, which sets this value to 20. So now we know this value is 20. Lastly, we'll print out get servo count. So it's this function, which calls this get servo count, calls this get servo count, which gets this variable, which is 20. So A delivers the value we need. Let's just kind of review the next to make sure that they are not also correct. So here we start off again, Android X, so we're going to set that to 10. We're setting this servo count to 10. Then we call set servo count to 20, which is the same as what we did before. So that sets servo count to 20, set servo count 20. But then we call get local. So here we are, get local, which points to this servo count. So we've set this to 20, but this is 0 because we haven't initialized it yet. So this is going to print out 0. So that's not correct. We do the same, start off the same way here. But here we set local equal to 20. So setting local equal to 20, that sets, so we start off, this is 10 and this is 20. And then we call get servo count. So we call get servo count, which calls this get servo count, which is what we remember is 10. So that's not correct. Lastly, we have setting Android to Y. We're setting that to 20. Then we set this to 10. So this is 20. This is now 10. And then we print out local, which is 10. All right, so none of these answers are correct. The answer is A. Question number 2. Consider the following class definition. Here we have a backyard, and we have private members length and width. The constructor will set those length and width. We have get the getters, which will get the length and get the width. And finally, we have this function called equals, which takes in an object and compares it to the object's length. So we have one backyard object taking another backyard object inside of it and then compares the lengths and compares the widths. The following code appears in a class. It is intended to print true, so this is what we want. It's intended to print true if B1 and B2 have the same lengths and widths, and print false otherwise. So let's take a look at this code. Backyard 1 equals X and Y. Backyard B2 equals J and K. So we're assuming that X, Y, J, and K are correct. Let's take a look at these particular answers. First one, B1 equals B2. So here we are when we're comparing two objects with the equals operator. We're comparing memory locations. So when we're comparing objects, we're comparing memory locations. So we're not necessarily comparing lengths and widths. We're comparing does this object equal this object in the, does it equal the same space in memory? And that's not correct. B. B1 equals B2. Okay, this uses this equals function. Here I have a backyard object, and I'm taking another backyard object in, so it's one parameter. And here I take the object, so I take this particular B1's length and compare it to B2's length, and compare B1's width with B2's width. Now this is a slightly problematic item because this is a binary and instead of a double ampersand. They probably meant double ampersand like this one here, so we're going to assume that's the case. So we'll take B is probably correct. This is probably a misprint here. Next one, equals B1 equals B1 and B2. There is no definition of a method called equals. First off, this equals is a member function, so it needs to look something like this, where I have a class and I call dot equals. This equals doesn't exist anywhere in our code. And this also takes two parameters. This is taking one parameter, so C is not correct. Let's take a look at D. So this is correct, dot equals, so we have B1 dot equals, but it takes in two parameters, get length and get width, where this equals only takes in one. So we know it can't be D. Lastly, this one looks correct, where I'm comparing B1 length and B2 length, but notice that length and width are private members. Here, when I'm declaring this, it thinks that these are public. It can't access length and width of B1 and B2 because they are private, so E is not correct. The answer is B. Question number 3. Here we have class dog, and we have a class underdog, which extends dog. So it looks like we're going to have a lot of tracing to do, so let's get to it. Assuming that we have a variable dog Fido equals new underdog, what is printed out if I call Fido.act? So here we have an act and an eat in dog, and then we have an act and an eat in underdog, which overrides the superclass. And also it calls the members. So let's keep a finger where we're going to go, and we'll see what's going on. Here we have act. We call act in the underdog class. So we put our finger right here. We're calling super.act. So we're going to leave off right here and call super.act. Here in super.act we call run. So run is the first thing we print out. We take a look here. It looks like all of these answers start off with run. So we're in a good place. Then it calls eat. Now, because we've overridden eat, we're not going to call this eat directly. We're going to call this eat. So here we are. We're going to place a finger right here at super eat. Super eat is going to call this eat. So here we are printing out eat. So the second one, eat, is correct. All right. Now that we're out of this function, we're going to come back to where we left off, and we print out bark. So bark is the third option here. So that probably has this as the answer, but we'll keep going. All right. Then we come back out, and here we are where we've just gone through the act, eat, and we were out. Finally, this is the last place where we kept our finger. We print out sleep. So run, eat, bark, sleep is our answer. Question number 4. All right, we have a bike class, which has a variable get number of wheels and a function get number of wheels, which returns it. Then we have e-bike, which extends bike. And then we have a variable number of watts and a function that gets number of watts. We also have a constructor here, which takes in number of watts. We have a chunk of code where we create a new e-bike and assign it to bike. And then we try and print out get number of watts and get number of wheels. So something's wrong. We have to figure out at what point does the thing go wrong. Let's take a look at A. A, the bike superclass does not have a constructor. That's true. It doesn't have a constructor, but that's okay. A superclass doesn't need a constructor. By default, it has a 0 parameter constructor. So A is most likely not it. B, there are too many arguments to the e-bike constructor. All right, well, let's take a look. E-bike constructor has one parameter, which is 250. We take a look. In here, we have a constructor that takes in an integer. So, nope, there's only one argument. That's correct. That's not the, B is not the correct answer. Let's take a look at C. The first line of subclass is not a call to the superclass. That's true. This first line is not a call to superclass, but if we know our constructor rules, that's okay. We don't necessarily need to call our constructor. It is implicit. It is implicit if we don't call super here, it'll automatically call that. So we know it's not C. D, the get num of watts is not found in the bike class. Let's take a look. So here we print out B get num of watts. At this point, we know that B is in e-bike. We know that it is, but the compiler doesn't know that. All the compiler knows is that it's of type bike. So we go and see, is a function called get number of watts available to bike? And looking at it, at the definition of bike, no, we don't see anything in here that for a function called get number of watts. Even though we know that e-bike, humans know that an e-bike has a function called get number of watts. But at this point in the program, the computer doesn't know that. It can be anything. So it will fail right here because it will try to call get number of watts and it says a bike doesn't have a get number of watts. So the answer is D, get number of watts. Question number 5. We have an Apple class which has a method print color which prints out red. We have Granny Smith which extends it and overrides it so it prints out green. And lastly, we have Jonna Gold, which doesn't do anything. It just takes whatever the default is. We have some code that has some apple.print color. We want to know under which circumstance will it print out red. So let's take a look. So when some apple is of type apple, when some apple is of type Granny Smith, and when some apple is of type Jonna Gold. Well, we know apple, by default, will print red, so 1 is correct. When a Granny Smith prints out color, it's green, so we know that 2 is not correct. It won't print out red, it'll print out green. Lastly, we have Jonna Gold. Jonna Gold doesn't do anything, so it'll take the default, which is red. So the answer is 1 and 3. We'll take a look down here, and we see that C is 1 and 3, so the answer is C. Question number 6. Consider the following class definitions. We have a road, and we have a string road name, and we have a highway which extends road. So we know that highway is a road. The following code segment appears in the method in another class. We have road 1 equaling a new highway. We have road 2 equaling a new road. We have highway R3 equaling a road, and highway R4 equaling a new highway. Let's take a look. Something's wrong. Let's figure out what that is. Line 1 will cause an error because a road variable cannot be instantiated as a type highway. That's not correct because a highway is a road. We can assign a new highway to a road because a highway is a road. I can say road is a highway. Line 2 will cause an error because the road constructor is not properly called. Let's take a look. The road passes in with string. Here we are a constructor. It passes in a string, so that's not correct because that's working. This is the right way to call a constructor, so we're good there. B is not it. Line 3 will cause an error because a highway variable cannot be instantiated as an object of type road. So while we can say that a highway is a road, we can't say that a road is a highway. So this is correct. This is the error because we can't necessarily say that every road. I can say that all highways are roads, but I can't necessarily all roads are highways because what if I have a circle, or a boulevard or whatever? That these things are roads, but they're not highways. So remember that an is-a relationship is a one-way street. So the answer in this particular question is C. Question number 7. Consider the following class definitions. We have a pet, which has a function called speak. We have a dog, which extends pet, and we override speak, and we call this function bark. And this class also has a function bark, which prints out woof woof. And lastly, we have a cat, which overrides speak and prints out meow meow. So we have a mypet.speak, which one will compile and run without error. So if we have of a type pet, if it's just a generic pet, and we call speak, will that work? Yes, that'll work because all we have is just this function here, so we know that 1 is correct. It'll work. When my pet is of type dog, dog has overridden speak, which is fine, and it calls bark, which is fine. So we know that dog works. Lastly, my pet is of type cat. So cat is overriding speak, so speak is valid, and it prints out meow. So in this case, all 3 are correct. So if I look at the answers, E is 1, 2, and 3. So the correct answer is E. Lastly, we have question 8. Consider the class definitions. We have a book, which has an author and a title. And we have a constructor that takes in 2 string parameters, the author and the title. And then we have a textbook, which extends book, and it has a constructor that takes in 3 parameters, the author, title, and subject. So in this particular question, we got to determine which chunk of code is valid that won't return an error. So let's take a look at the first one. Author, title, and subject. So it looks like this is correct, where I assign author to the author, title, title, subject, subject. But if the code is put here, then we have to understand that we don't have access to author and title. These values are private in book. So if we tried to put this code in this section here, it would fail because it doesn't know anything about author and title because they are private. So A is not correct. Let's take a look at B. There's a super where we're going to call the super function, the super constructor, and we pass in author and title. So this is fine. This top one's fine. But then we take a look at the second one, super the subject. There is no constructor with the subject with a single variable. So we know that B is not correct. C looks correct. Here we are. We're setting subject to the subject and then calling the constructor, which then sets the author and title. So that looks correct, but remembering our rules about constructors, super has to be the first method called in the constructor. If we try and set subject ahead of it and then call super, then it will not compile because it breaks the rules of constructors. Super must be called first. So let's take a look at D. D is correct because it's the same thing as C, but flipped around where super is called first. So we pass in the author and title, that gets assigned, and then we set subject equal to the subject. So that looks correct, but let's take a look at this last one. We have a super call, which calls a 3-member constructor. The book doesn't have a 3-member constructor, so the correct answer in this question is D. That concludes the inheritance questions. Thanks for watching.